Okay, you asked what extrapolation means. Well, when we're dealing with linear regression, you'll usually have some points in a line. Now, the data that you have is only going to cover a specific range of x values. So here's a problem that I like, where the x value is your temperature and your y value is the amount of natural gas used to heat your home. And these temperatures will usually range. You'll probably have data from about 0 degrees, to about maybe 60 degrees. And you're like, oh, look, as the temperature goes down, oh, that's not going to make much sense, is it? Oh, wait, no, that was right. Okay, sorry. As the temperature goes up, I just said it wrong. Okay, so as your temperature goes up, the amount of gas that you need goes down because you don't have to heat your home. Okay. So you have all these points. They seem to be very nice. As you go along, you have a nice line. But your data kind of stopped at about 60 degrees. Now the question is, if I want to extrapolate, which means my data only goes to 60, if I try and guess how much fuel I'll need past 60 degrees, because it covers x values that weren't in my original data, this is called extrapolation. To extrapolate means to go beyond your data. So my data only goes to 60. If I start trying to make predictions past 60, that's called extrapolation. Now, the thing about extrapolation is it might work and it might not. So maybe at like 66, my prediction is okay. But what happens after that? If you keep following the line down, then you'll get down here and somewhere around like 90 degrees, it crosses over. And so at this point, like if you were down here, that means that if the temperature outside is 100 degrees, you're actually using negative gas. So that means your house is somehow spontaneously producing gas. That wouldn't make any sense. So by the time you get over here, all of these predictions are going to be completely bogus. So that's why extrapolation is dangerous. Okay, so the problem about extrapolation is you don't know, does the line go down straight and keep going? Or maybe the data for some reason kind of levels off. There's a lot of things in nature where it kind of goes down in line and then it changes and levels off. You might even have situations, not dealing specifically with temperature and gas, but you might have situations where the line goes down, but then it starts going back up. So the problem with extrapolation is we just don't know what's going to happen. We have this nice little line for specific x values from 0 to 60, but then after 60, we don't know what happens. Does our line go down? Does it kind of come down and level off? Does it come down and go back up? We just don't know. So by the time you get out here, you might try and make a prediction for 90 degrees, but what's it going to be? We really don't know. So that's why extrapolation is dangerous. If you try and make predictions for anything outside the x values of your data, it's called extrapolation, and your results might not be accurate.